So now we will see how to get the first answer of the Riemmer Tiemann reaction, and then we will go with the mechanism. See here. So in the first reaction you take phenol, okay, and you understand here also this was a phenol, but remaining is CH, 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 CH here also. So here also there is one H, you have to remember this, because this H will also help when we will do the mechanism, we will understand in detail. So in first product it will be CHCl3 by reagent, another reagent is NaOH. So now what to do? Split it. It will get here CHCl2 and plus Cl. So now how to get? See, first this OH and this H will form H2O. Clear this part? Or you can take this as H and this as OH. So one and same, because this is a phenol will give you H because it is acidic, so H plus, and this will give you as OH because it is a base. So H and OH will generate what? H2O. Now what the change will occur? The change will occur is there is O here and Na will be here. So ONA will be generated. Clear? Now see what happens. This ortho position hydrogen and this Cl will generate HCl. So there will be one empty space here, and here there will be CHCl2. So this product will be generated. Clear? In the first step. Now, how many Cl are there? There are 2 Cl. How many Cl? There are 2 Cl. So what I have to do? I will take here 2 NaOH. In second step, I will take 2 NaOH. So I will split here. See, I will take here NaOH and NaOH. So here 2 Na and here 2 Cl. So I will form here 2 NaCl. Clear? There is one H here and there is one OH here. So I will form here H2O. And what is remaining? Here remaining is O and there is remaining is here CHO. So what will be generated? Here generation will be ONA and CHO. So this will be generated. Now I shown you have to form the salicylaldehyde. For the salicylaldehyde there should be H here. So what I will do? Now I will do the acidification. I will react with HCl. So here plus, here minus. So minus and here plus. So this Na plus will react with this Cl minus, forms NaCl, and next step will come. Here there was CHO and here there is OH. So this is nothing but your salicylaldehyde. Clear? A simple. So this is I am showing without the mechanism how to get the directly answer. Clear this part? Take a screenshot. So now we have seen how to do the Riemmer Tiemann reaction. Okay, I taught you how to get the answer. Now we will see how to do the mechanism of Riemmer Tiemann reaction. So make a heading: mechanism of Riemmer Tiemann reaction. Okay, see here also there will be one IP, intermediate product, which you should remember, and many a time it has been asked out of this question. Okay, so see, first step we are taking the chloroform. Clear? This chloroform, as you know, these are the chlorine which are more electronegative elements, so electrons are attracted towards it. Okay, sorry, electrons are attracted toward this. So this carbon will create more positive charge, hence this is a more acidic hydrogen. So as this is a more acidic hydrogen, it can be removed easily. So here what will happen? Will react with this NaOH. So NaOH will provide us OH minus. This OH minus will react with this H and forms what? Water. You remember this one Na plus also here, okay? And what will be generated? See here now. So see, here Cl, here Cl and here Cl. So H is going as H plus. On H plus will go, what will create? It will create minus charge. So now there is a one electron of the carbon and H is going as H plus. H is going as H plus. So H plus means 0 electron. So here H is not taking the electron, instead he is giving the electron and going. So there is one electron extra. Clear? See how this electron is coming here. This electron is of the carbon, bond broken, and this electron is of the hydrogen. The hydrogen is going as H plus. H plus means how many electron? 0 electron. So there is no electron taken by the hydrogen. Instead hydrogen is giving electron to this carbon. So carbon will have 2 electrons, 1 electron of its own and 1 electron of its hydrogen. Clear? So this formation will occur. Now what will happen? There is a minus charge on this carbon. When there is a minus charge on this carbon, so this will be highly reactive species. So this reactive species has to be stable, because presently it is unstable. Now it is a unstable, so you have to make the stable. So this chlorine, as you know, the chlorine is a very good leaving group. So this chlorine will take the electron and release as Cl minus. This Cl will take its electron and go as Cl minus, and there was Na plus here, so it will form a NaCl. It will form as NaCl. Understood? In the first step, H2 and NaCl is forming. So this Cl will go as Cl minus and forms that NaCl. So what will happen? See, now this Cl is taking the electron and it is going. Now we'll see. Here there are chlorine, here there is a chlorine, and there are two bonds. Whether sign should come or sign should not come. See, outermost orbit electron you see of carbon, 1, 2, 3, 4. Carbon can make a outermost orbit electron of carbon are 4. Here also outermost electron of carbon are 4. So no sign will come. So this species will be generated, and this species is known as a dichlorocarbene. Please remember, this is the intermediate product formed during the Riemmer Tiemann reaction. Dichlorocarbene. Understood how the formation of dichlorocarbene is formed? You take chloroform, and this H, this is an acidic H, will be removed with the base, so H2O. Now H is going as H plus, means 0 electron. So there are 2 electrons will be remained on the carbon. 1 electron of the carbon and 1 electron provided by the H. So there are 2 electrons here, and there is a minus charge because H is going as H plus, so it will generate here minus. Now this chlorine is a very good leaving group, so Cl will remove as Cl minus, and there is a presence of Na plus, so NaCl will be formed, and there will be generation here of dichlorocarbene. This is known as a dichlorocarbene. Why? Understand, see, there is a, why it is known as an ene, why it is an alkene? See, there is a single bond. Then also I am saying as alkene, double bond. Why? We will see. See, there is one lone pair, there is 2 bond pair and 1 lone pair. So totally there are 3. 3 means which kind of hybridization? sp2 hybridization. And sp2 hybridization means who is having the sp2 hybridization? Double bond. So this is the compound which is having a single bond but showing sp2 hybridization. That's why we are calling as a dichlorocarbene. Understanding? Why it is carbene? Alkene, no, alkene ene means double bond, but there is a single bond. So you would be wondering, so why single bond? Then also you are telling ene, it should be carbene. ANA single bonds. Why it is carbene? Because of this logic. At chemical bonding, there are 2 bond pair and 1 lone pair. So totally how many? 3. 3 means which kind of hybridization? sp2 hybridization. So what is the carbon here hybridization? sp2 hybridization. And sp2 hybridization is having which? When carbon is having the double bond. That's why it is carbene. Okay. So this is the carbene compound which is showing this is type of a, this is the carbon which is having the sp2 hybridization with a single bond. It is very, very important. Many a time this question has been asked. Okay, what is the hybridization of a carbon and dichlorocarbene? sp2 hybridization. So one thing more. See, this is 1, 2, 3, 4, 5, 6. Yes or no? See the outermost orbit electron. The outermost orbit electron are how many? 6. 1, 2, 3, 4, 5, 6. So there is a, the octet is not complete. Means they require the electron. When they require the electron, means they have a capacity to gain the lone pair. Means they will act as a Lewis acid. So they are also known as a Lewis acid. This is also a very one important question. They are also known as a Lewis acid because they need an electron. Yes or no? See the outermost orbit electron 1, 2, 3, 4, 5, 6. Still they required 1 lone pair to make stable. So they need an electron. So when the compound which have a capacity to attract the electron, they are known as a Lewis acids. So dichlorocarbene is one kind of a Lewis acid. Dichlorocarbene hybridization is sp2 because of this logic. Clear this part? So this is our intermediate product which will be taken consideration during the mechanisms. Clear? Now we will see the mechanism. See what happened. In the mechanism, in the first step, we are taking the phenol. Clear? We are taking the phenol and we are reacting with NaOH. Clear? Now we will see 1, 2, 3, 4, 5, 6, 7, 8. So this is a minus and there is a plus. So there is a minus, there is a plus. So they will react with this, so it will release this place. So what will happen? I will show with the bonds here. So there will be generation of H2O here, will be generation of O, double bond, H will go as H plus, so minus will be generated here and 1 lone pair will come here. There is 1 bond pair here, 1 bond pair here, 1 lone pair here. Clear this part? Clear? Now what will happen? Now this out of 3 lone pair, 1 lone pair will be donated to this carbon. So when there is a new bond, so old bond should be broken, which I have shown in the resonance of phenol. So this will take place. Here there will be double bond. Out of 3 lone pair, 1 lone pair has been given, and carbon can make a double bond, so now no sign will come. So minus charge will go. And this bond breaks and negative charge will come here and here. Clear? Now this carbon is having the negative charge. So this carbon is having the extra electron. Yes or no? This carbon is having the extra electron. When this carbon is having the extra electron, there is a dichlorocarbon which needs the electron. So I write down in this way, 1 and 7. No? This is a dichlorocarbon, it's a Lewis acid, means need of an electron, and this carbon is having the extra electron. So this carbon will donate its electron to this carbon of dichlorocarbon. So what the change will occur? See here. So there is aromaticity, I have destroyed the aromaticity, see. Now this negative charge which is having the extra electron, this carbon which is having the extra electron will be donated to this carbon of dichlorocarbon. Why? He will donate to the carbon of dichlorocarbon because dichlorocarbon is acting as a Lewis acid. So he will donate its electron to this carbon. And what will be the generation? So this will be get generated. Double bond here, double bond here, 2 lone pair, and here bond with carbon. There is 1 chlorine here, there is 1 chlorine here. Clear this part? So this generation will take place. Now what will come? How many chlorine are there? There are 2 chlorine, so 2 NaOH will come. How many NaOH will come? 2 NaOH will come here. So 2 NaOH will do the reaction here. What will happen? This 2 Na will react with this 2 NaOH. Okay, so how? I write down in this way, NaOH plus NaOH. So this is OH, no? So this OH will attack on this carbon and this OH will attack on this carbon and this chlorine will be removed. Means here SN reaction will take place. See, OH minus is replacing Cl minus. So here SN reaction will take place. Now what will occur? See, this will occur. There was double bond O. Okay, there was here double bond. Here there is carbon and here there is OH and here there is OH. Now see here. But 2OH on such a type of carbon is unstable. So they will become stable by removing the water in this way. So water will be removed as H2O. And what will be generating? Here they will generate double bond oxygen and here there is CO. Yes or no? So this bond will get shift here and C double bond will be there. Clear now? Now see here. 1, 2, 3, 4. So 1, 2, 3. Still 1 bond is required. Now, as we know, there is a 1 carbon here. As we know, this is a benzene, no? So this benzene means what? CH here also is there, CH here also is there, CH here also is there. So there is C, but there is 1 more H here also. Yes or no? CH, CH, CH. So there is 1 C, but with C there is 1 H. So what will do? This H will give its bond here, will regain back the aromaticity. So here new bond is formed. So your old bond will be broken. So what change will occur? See here, the change will occur is this. Do not worry, I will do again mechanism. This board is very small, that's why. So 1, 2, 3, 4, 5, 6. Here CH will go as H plus and here this is minus, so it will form here CHO. Clear? Because here this carbon, this H will release as H plus and here will be forming as CHO as a bond here. Clear this part? Clear? Okay. So here CHOH and here there is a bond of CH. Clear? Reaction is okay, so this is nothing but your what? Dichlorocarbon. Okay, if you see there are 2 bond pair plus 1 lone pair. So totally there are 3. So it is sp2 hybridization. Okay, if you see the outermost orbit electron 1, 2, 3, 4, 5, 6 need electron. Need electron means they Lewis acid. So many things are there. Okay, so Lewis acid. So now this dichlorocarbon will help us to do the mechanism of Riemmer Tiemann reaction. Now say first step. In the first step we are taking the phenol. We are taking what? Phenol. I will show the bond in this way. First step, NOH will come in the picture. NOH will come in the picture. What will happen here? This is minus and this is plus here. So this plus and this minus. So this H will react with this and this place will be released and forms what? H2O. And here there will be formation of O minus. Now count the electron 1, 2, 3, 4, 5, 6, 7, 8. There is bond here, there is bond here, there is bond here. Now resonance will take place. So this lone pair will shift here and this bond will be broken here. So what is the change will occur? See the change. The change will occur is here double bond O, there will be 2 lone pair. This bond breaks and minus charge will come here. Here aromaticity is gone. The aromaticity is broken now. Now this carbon is having the extra electron. How I come to know? Because of this minus sign. Minus means he is having the extra electron. And this dichlorocarbon needs the electron which is forming from the chloroform in NOH. So this dichlorocarbon now react with this carbon. So see how. So this is dichlorocarbon. Okay, there is extra electron. So this they have a need, they have extra electron and they need electron. Why they need electron? 1, 2, 3, 4, 5, 6. So they need electron. So this carbon will donate its lone pair to this carbon and bond will form between the carbon of dichlorocarbon and between this carbon. So what the change will occur, we will see this. Say this will be occurring. There is bond here, there is bond here, double bond O, 2 lone pair and 1 C, Cl and Cl. So who has given the electron? This carbon, he has given the electron to this carbon. So this carbon has taken the electron, so minus charge will come here. Clear? Now you see the benzene. So this is the benzene, yes or no? Benzene means what? C6H6 means here there is CH, 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 here there is CH. Similarly, here there is CH, yes or no? So this C is making bond with this C, but there is one remaining H is also there. So this H will now come into the picture. Understand, no? When I was doing, I have shown the H of the ortho position. Now H, what he will do, as this aromaticity has been gone, so this H will donate its lone, this whole bond here. So when a new bond is formed between these two, this bond will be broken and H will be removed as H plus, yes or no? This H will be removed as H plus and this bond will come downside, so aromaticity will be gained back. So here there is a new bond, so old bond should be broken, so H is removed as H plus and C is minus, so they two will do the reaction. So what change will occur? See here, see this. See, this H is giving its whole bond here. Okay, so out of double bond, single bond will be there because one bond will be broken and O. So bond is entering into this O, so create minus charge. Now count the electron. There were 2 lone pairs previously. One more lone pair will come. See 1, 2, 3, 4, 5, 6, 7, 8. Now what? This H is removed as H plus. Will be reacting with this carbon. So carbon will be having this H, this Cl and this Cl and one bond. So aromaticity is back gained. Understood now? Now what will happen? Now SN reaction will take place because there are 2 chlorine. So I have to replace 2 chlorine with 2 OH minus. So I will take 2 NaOH. Okay, how will I take 2 NaOH? See here NaOH, here NaOH. Okay, this OH will attack on this carbon, Cl will be removed. Similarly, this OH will attack on this carbon and Cl will be removed as Cl minus. So here 2 NaCl will be generated, Na plus, Na plus. So what will change will occur here? See the change. Double bond, double bond, double bond. Here O minus with a 2, 3 lone pair. So here C, OH is attacking to the C. So Cl is generated. So SN reaction. See, substitution of nucleophilic reaction. I have attached nucleophile on this carbon to remove a nucleophile. I have attacked a nucleophile on this carbon because OH minus is a nucleophile. So I have attached a nucleophile to remove a nucleophile. So substitution nucleophilic reaction, SN2 reactions. Okay. So now see here, OH will be attached on this carbon. So Cl will be generated as Cl minus. So there is an Na plus. So one NaCl. Similarly, another OH will attack on this carbon. So Cl will remove as a Cl minus. So there is a Na plus. So NaCl. Clear this part? So 2 NaCl will be removed. And what is the change will occur? Here C, there was H. One OH will come here. One OH will come here. Now, on this type of a carbon, 2 OH is highly unstable. So they have to gain stability. So how they will gain the stability? H of this and OH of this will be removed as water. So what the formation will takes place? The formation will takes place is this and O 3 lone pair and minus. Here there is C. So when H is removed completely, so this bond will get shift to this carbon, means this oxygen. This as OH is removed, no, so this bond will get shift here. So there will be double bond between carbon and oxygen, and there is one H previously only. This is nothing but a what? Aldehyde. Now what? Now what is remaining? This O minus. So what I will do? I will do the acidification. H plus. When I do the acidification, what I will get? I will get here. This is bond. This is O minus. So O minus will be reacting to this H because H plus is having 0 electron and they are having 3 lone pair. So 1 lone pair will be donated to this H. So there will be bond between this OH. 2 lone pair will be remaining, no sign will come, and here C double bond O and H means what? CHO. So this is nothing but what here? Salicylaldehyde. Clear? It bit clumsy, please understand, okay? Understood this portion? Yes or no? So in this way you have to understand. Clear? Shall I explain once more? Okay, understood now this mechanism? Okay, see once more we will see this mechanism. Take a screenshot now. Okay, once more I will do the mechanism. Understood this dichlorocarbene and all? Okay, once more we will do the mechanism. Okay, I will go once more with mechanism. Take a screenshot of this dichlorocarbene, that is very important. Clear? Now see, what will happen? First come phenol. First who will come? Phenol will come, and instead of this bond I am showing this bond, OH. Clear? And here it will come NaOH. So this NaOH will provide us what? OH minus. Here minus, this OH minus will attack on this H, so H will be removed as this. So O will create minus. Yes or no? This will be removed in H2O. So 1, 2, 3, 4, 5, 6, 7, 8 and 3 bond will come here. This is the first step. Clear this part? This much you understood everyone? Now what will happen? Now simple, we will do the resonance. So I will move this bond here. So this bond will get break and enter into this carbon. So what will happen? See, this will be generated. Double bond with oxygen. Out of 3 lone pair, 1 lone pair has been gone, and here minus charge will come. Here aromaticity is over now. Now, this dichlorocarbene needs electron and he is having the extra electron. So, what he will do? This carbon will donate its electron to the dichlorocarbene. So, this dichlorocarbene, which is IP, and this carbon will donate its electron to this dichlorocarbene. So, what the generation will takes place here? Generation will takes place is double bond O minus 2 lone pair. This carbon will gain electron, creates negative charge, and here there are 2 chlorine. So, this change will occur. Now, as well this is a benzene, and benzene ring will have CH. So, C and there is one more H here also. So, now what will happen? This hydrogen will give its back aromaticity by donating its whole bond to this carbon here. So, when a new bond is formed, this old bond will get break. So, what will generate will takes place? See, double bond is converted to single bond. So, O minus, there will be 3 lone pair. Okay, this bond will be formed. Here there will be C, here there will be Cl, and here there will be Cl. Clear this part? And H is removed as H plus. Here H will be removed as H plus, and there is minus here. So carbon will make a new bond with this H. Clear? And aromaticity is gained back. So this change will occur. Now what will happen? Now substitution nucleophilic reaction will occur. This Cl should be replaced because this can be removed easily. So what I will do? I will do NaOH. So I will take here NaOH. Plus 2 moles of NaOH I will take. So what happens? out of this Na plus OH minus, Na plus OH minus, this minus will attack to this carbon and remove HCl as Cl minus. Similarly, this minus will attack to this carbon, remove HCl as Cl minus. So there will be formation of 2 NaCl because Cl will be removed as a Cl minus and there is Na plus here. And there will be attacking of here OH and here will be OH. So what the changes will occur? See here. There were 3 bond here. There was O minus. Okay. There was C here. Now Cl is replaced by OH. OH and here Cl. Now on this type of a carbon, 2 OH group are highly unstable, so they will gain stability by removing the water. H here and OH here, what will generate? H2O. So H hold this bond will shift to this carbon and will form here double bond, double bond, double bond, O minus 3 lone pair and here C double bond O and H, that is nothing but CHO. Now I will do the acidification. If I do the acidification, I have to give H plus, means 0 electron. Out of 3 lone pair, 1 lone pair will donate to this H, OH, okay, and C double bond OH means what? CHO. So in this way, salicylaldehyde is formed. Take a screenshot. In this way, you have to do the mechanism, which is very, very important. Take a screenshot. Chala. Clear? So this is the mechanism of a Riemmer Tiemann reaction. Write it down. Thank you.